Section 4 deals with our inverse trig functions. We had six trig functions that we dealt with. There's also 6 inverses. But for the sake of time here, we're just going to deal with our inverse sine, inverse cosine, and inverse tangent functions. And we've also had some exposure to these. An example would be this right triangle trig problem, where I'm trying to find the measure of angle A using this leg opposite and the hypotenuse. And at this step right here, we use the inverse sine function of our ratio, opposite over hypotenuse ratio, to find the given angle. And depending what mode we're in, we can find that angle in degrees or in radians. Although we have used the inverse trig functions, we've never really kind of delved into their definition, and we really have to be careful when we deal with these because there are some limitations. In terms of notation, any inverse function, we try and in math use our -1 as an exponent to represent the inverse, and you'll find in our presentation here that it doesn't deal with exponent notation very well, and so all these -1s should be exponents. And so this right here would be the notation for the inverse sine. And so the inverse sine function has a limited domain of -1 to 1 because we have to remember about inverse functions. What a function does, the inverse undoes. And so when we take sine, and what we're dealing with here is the inverse sine function, so we need to look at the sine function, what the sine function does. Given some angle measure along the unit circle, the sine function is going to tell you what the y-coordinate is, and the largest possible y-coordinate is 1, the smallest value is -1. And so that output of your function becomes the input of your inverse. And so there's our domain of -1 to 1, because that was the range of the sine function. Now, in terms of the range of our inverse sine function, what we need to do is let's go down and look at this graph right here. And this graph is y equals the sine of x. And like we said, the inverse function undoes what the function does. And so what the function does for us is it gives you the y-coordinate on the unit circle for whatever angle measure. And so given some angle measure, theta, we can interpolate, go up until it hits the graph, and come over and find out what the y-coordinate of our unit circle is. Well, the inverse trig function basically does the opposite of that. Given your y-coordinate here, given your y-coordinate here, what the inverse trig function does is it allows you to go in and find what angle gives you that y-coordinate, but the problem is, because of the periodic nature of the trig functions, just in this part of the graph you can see that there's 2 possible answers. And we know that these trig functions go on forever, and so there's an infinite amount of answers for this angle. How many angles have this y-coordinate? And so what we have to do is, to make the inverse sine a function, we have to limit the domain of the sine. And that's what this pink box does here, is it gives us a range of values that we limit to, so that when we take the inverse sine of a number, of a ratio or of a y-coordinate, we're only going to have one possible angle that meets that criteria. And so when we go and graph our inverse sine function, and really all we have to remember is that the inverse sine function's graph is a reflection over the line y equals x of the sine function. Now I think let's go and look at some, I think we can build our best understanding of the inverse trig functions by using them and just looking at questions that pertain to them. But once again, remember, this is our common theme here, what the sine does, the inverse sine undoes. And that's what we're looking at here on these slides. Let's suppose we're asked to find, right here, the inverse sine of 1/2. So in other words, what angle measure has a y-coordinate equal to 1? 1/2. And so over here on our unit circle is where our y-coordinate is 1/2. And hopefully you still have your unit circle values down, because the theta value that does that for us is pi over 6. Or, in degrees, would be 30 degrees. And so the answer to this, and proper notation, once again, remember that all these negative ones are exponents, or written as exponents. But the answer here would be pi over 6 radians, or 30 degrees. Whereas the inverse sine of negative 1/2, and this is where you have to be careful, because when we go and do this, it could have a couple possible answers. Because you could go in a positive direction. There's an angle with a positive direction that gets you to this point whose y-coordinate is negative 1/2. But there's also a negative rotation that will also do that for you. The positive rotation is 11 pi over 6. The negative rotation that does it is negative pi over 6. And so what we have to do is remember how our inverse sine is defined, and it's only defined to have a range of values. The output can only be between negative pi over 2 and pi over 2. And so this is the angle measure in that range of values that gives you a y-coordinate of negative 1/2. And so it would be negative pi over 6 or negative 30 degrees. Should be a negative sign there. And my next example here does not exist. DNE. The reason being is the input. The input of this has to be a value from negative 1 to 1. That's what our domain is of these inverse trig functions. Because that's the largest y-coordinate is 1, smallest is negative 1. And so you cannot take the inverse sine of something outside that range of values. So we will deal with problems like these two right here, where we're dealing with a value that's on our unit circle. But we could also have issues like these two here. I got to take the inverse sine of 0.82. Well, I'm going to use my calculator for that. And depending on what mode I'm in, I think typically in here, let's keep ourselves in radian mode. And this would be 0.9614 radians. But just to get some context to this, it would also be 55.0847 degrees. Now I think you should be following along with your calculators as we do these to make sure that you're doing them right. I'm going to go in and hit the inverse sine for 1/3. And in radians, I'm going to get 0.3398 radians, which is approximately 19.4712 degrees. Now the context of the problem will tell you what we should be in, but like I said before, radians is probably what we should be using most common, or most often. Now one of the big places for the inverse function is the whole idea of the inverse undoes what the function does. And so back when we covered inverse functions, we kind of looked at it as a assembly line. If f and g are inverses of each other, the input you put into f, function f does some work on it, and we take the output of f, puts it into g, and g undoes what f does, and we end up with the same output that was input. And that the sine and inverse sine functions will do that for us as long as we keep track of the range of values that it works at. And this is the situation we really have to be concerned about, because problems can arise if you're not concerned about the input here of negative pi over 2 to pi over 2 in this in this application of the inverse function property. Now let's just look at a couple of examples here. And I think a lot of times it's nice if we can go to the unit circle and help us gain context of this. And so the first thing they're asking us to do is take the sine of the inverse sine of negative 1/2. Well, if these were true inverses without restricted domains, we could just say our answer is negative 1/2. But let's take a look at this now. And what we have to do is, and we just did this previously, and so we're over here, our y-coordinate's negative 1/2, and we said the value that did that was negative pi over 6. And so we're asked to find, if we do this step by step, this is basically saying, well, what's the sine of negative pi over 6, which is negative 1/2. And so our input here and our output here are the same because we followed the restrictions on our input. Our input was a value between negative 1 and 1. Now, let's look at this situation, and I think we just talked about this. We have a situation here because we're trying to take the inverse sine of a value outside of that range of values, negative 1 to 1, and so we get into that situation where we just can't evaluate. And so in this order of the inverse function property, we're trying to take the sine of the inverse sine. The only limitation is that our range of values has to be between negative 1 and 1. Now let's look at the other order. Let's look at the order where we're going the inverse sine of the sine of a value. And once again, they should undo each other, but because we have some restrictions here on our input on the sine, you have to be careful. And so what we have here are 3 different inputs, and what we'll find is the output of all 3 of these is going to be the same. And so that's why we have to be careful. And so the first one, negative pi over 4, does put us in the 4th quadrant. Our y-coordinate there is negative square root of 2 over 2. And so we would essentially here be asked to find out what the inverse sine of negative square root of 2 over 2 is. And in a restricted domain for the sine, we have to remember that our restricted domain keeps us in the 1st and 4th quadrants. And so I always kind of keep that little red box around the 1st and 4th quadrants when I'm dealing with the inverse sine, just to remind myself what the domain is, or what the possible outputs are. And so then this will go to negative pi over 4. And so input and output are the same because our input was in that range of values. Well, let's look at the next situation where we're doing the inverse sine of the sine of 7 pi over 4. Well, 7 pi over 4 puts us in the same terminal point as the first one does. And so our y-coordinate is square root of 2 over 2, negative square root of 2 over 2. But because of the defined properties and restrictions of the inverse sine function, the output of this is not going to be the same as the input, because the inverse sine of negative square root of 2 over 2 is always negative pi over 4. And if we look at our third example here, where we're inputting 5 pi over 4, which is our 3rd quadrant, we still are a situation where we have the same value for our y-coordinate. And so we're going to be asked to take the inverse sine of negative square root of 2 over 2 again, which is negative pi over 4. And so that's why we have to be careful when we're taking the inverse sine of the sine of a value, because we're not guaranteed that our output is going to equal the input.